rerun of this. I mean, do whatever you want to do. It doesn't really pick up the background stuff very much, so. Okay, so I worked out these problems as well, and I really just want to make sure that you can see the answers, but also just talk about like making sure the formulas that you have on your formula sheet. I'm gonna hold this microphone so my voice doesn't go in and out for them. So 8A and 8B, to me, those are the biggest sections. Well, maybe 8B. 8B is the biggest section on the test because we had all those formulas that we were using. But 8A, I definitely put some questions on the test, like 8A, where you have to like think about, is it exponential, is it linear, and then answer the question. And so on 13 and 14, those were both exponential because it's going up by 1% each year. And you could totally figure that out by like taking times 10% and then adding it to the original amount and then keep doing that for every year. But we talked about that I think a really great formula to have is you take the original amount times 1 plus the rate of growth or decay to the t power. To me, it's very much like the compound interest formula. But if it's decreasing, you have to subtract. So on number 13, the rate is decreasing at 15%. So find the new amount in 3 years. So I got $30.70. On 14, also decreasing by 10%. So again, that's how I know it's exponential. So I got 8,100 as my answer. But 15, if it's going up by 2,000 per year, every year it's 2,000. So that's what makes it linear. And so again, I don't really know a great formula for this other than like, to me, it's just slope-intercept. But I took 100,000 plus 2,000 times 5 years, because for 5 years it goes up by 2,000, or you could just kind of figure out that it goes up by $10,000 and you add that to the original amount. So 110,000. Questions about those? So there's a couple questions like that on your test. Then in 8B, we talked about doubling time, we talked about half time, we talked about the approximate formula, we talked about the exact formula. Those are the ones, like if you haven't made your formula sheet out, that I want you to make sure that you go through your 8B notes and you kind of write down the formulas that you need. You can also write down example problems if you want, right? You have a whole sheet of paper, so whatever you want to write down. But 29 says the initial population was 15,000 and it grows with a doubling time of 10 years. So they gave us the doubling time. So find the population after 12 years and after 24 years. So those, look, I totally did it like money. I wrote it as a money problem, but it's a population, which means it's not money. Sorry, it's people. So that's the formula where you take the original population times 2 to the t over time to double. Capital T is the time to double. The formula for half-life is just like that, except for it's 1/2 over t of the time to half. And then 39, and I answered this for a lot of people in both classes. It doesn't give you an initial amount on 39, but that's okay because it says by what factor will prices increase, and they don't have to give you an initial amount for you to figure out by what factor, which means you're just doing the t over time, 2 to the t over time to double. And so if they're rising 1.2% per month, I use that approximate amount formula, the 70 over P. So 70 over 1.2 means the time to double is about 58.3 months. And again, pay attention that the units have to be the same. So this is per month, but then they ask for 1 year. So you have to change it to months. Like it needs to be months and months or years and years. And so that's why I changed it to 12 for 1 year and 96 months for 8 years. And then that means like in 8 years, it would increase by a factor of 3.13. So if this started out with, let's see, gas prices. If gas prices were $3 a gallon, you would take $3 times 3.13, and that would be the new price. Or they're like more than tripling is what we're seeing. Okay, everybody okay with that? More 8B stuff on the back. Like I said, I feel like 8B is the biggest section in this. That 45 talks about the decline or the half-life of a function. Same formula, starting amount 1/2 to the t over time to half. If they give you the half-life, they've given you that value. If they haven't given you the half-life and they gave you the percentage, that's where you could do the 70 over P. And so again, it was 1 million. So if you don't type all the zeros in on your calculator, it's going to give you like a decimal, like 0.4, because that means like 0.4 of a million, which is 400,000. I just typed the zeros in because 1 million is only 6 zeros, but I just want to throw that out there. 51 says use the approximate half-life formula, discuss whether the formula is valid. I didn't discuss whether it was valid, but again, same type of question, but the population is decreasing at 8% per year. So the approximate half-life would be 8.75. Remember, the approximate formula works best for percentages 15% or less. So this one at 8%, that's a good that's a good way to do it. If it was decreasing by 20%, the approximate formula wouldn't make the most sense. And so that's what it means, like, does it make sense? But then it says, based on this approximate half-life, how many African elephants would remain in 2050? Well, we started in 2016, ending in 2050, so that's 34 years. My half-life is 8.75. And so that means, gosh, that's not looking so good for the elephants if they continue to decline. They would be down to 23,678 is what I got. All right, couple more formulas. The exact formula, and on the test, it's going to tell you whether to do the exact formula or the approximate formula, or maybe ask you to do both of the formulas. So that's definitely a formula you're going to want to write down. The exact doubling time is log of 2 over log of 1 plus r. The exact half time is the same formula, except for it has a negative sign in front of it, and that's going to give you a smaller rate. So that's the only difference between those two, and that's just the log button on your calculator. I know in the book formula it says like log 10 of 2, but log 10 is the log button, so I think it's easier just to write this formula down because it's just log button on your calculator. And so 55 says compare the doubling times with the approximate doubling time. So they want you to do both. So if you do the approximate, you just do 70 over 3.5 and you get 20 years to double. If you do the exact doubling time, you get 20.15 years. That's pretty close, right? If you get really crazy different answers, especially if the percent is less than 15%, I would go back and check your math. Also, notice, we talked about this, that in the approximate formula, you don't change the percent to a decimal. Like, you leave it at 3.5, like 3.5%. But in the exact formula, you have to change it to a decimal. So, like, maybe you could even, like, write an example out like that in your paper. And then using the exact time, what will the population be in 30 years? If it started with 100 million, so I just did the same formula that we did over and over again, and I got, like, 280.7 million people. Yes, no, maybe. And I'm going to post this, so.
54.
Yep.
This is 34 over 8.75, right?
Yep.
Where'd you get the 175? Right?
But I found the, like, 8%, but I have to find the doubling time. So I did 70 over 8 because it's t over the time to double. So if they give you a percent, you have to find the time to double. And it just happened to be close to the same number as the percent. It doesn't always work like that. Good question. Okay. All right, 8C. When we talked about 8C, we did some of the same stuff we did in 8B, but the other big thing from 8C is the growth rate, where it's like birth rate minus death rate. That's the other big thing. But number 15 had nothing to do with this chart. The chart was for the ones below it. But number 15, they gave us the population in 2017 was 7.5 billion, and they said, let's use the average growth rate between 1970 and 2000, which was about 1.6%. So it's really just like 51 and 55. Step 1 is I found the time to double based on that rate. Step 2, I used the formula, the original population times 2 to the t over time to double. And where did the 33 come from? Because I'm predicting the population in 2050, and I know the population in 2017. So it's just the difference between the 2 years that I know. And we got about 12.65 billion. And again, we have talked about, probably that's not going to be the population in 2050 because we're not growing at the same rate that we grew in those years. But 18 and 20, I'm not going to make you do this so many times on the test, but there's definitely going to be a question on the test where I give you a birth rate and a death rate, and I ask you to find the overall population growth rate. So remember, if they ask you to find the population growth rate, that's just birth rate minus death rate. And you can leave it as a decimal, or I like to make it a percent. So there's a bunch of these here, but 18 for China, there were 3 years, and in 1980, I got 0.144 because this was out of 1,000. So like make sure you're thinking about per 1,000 when you subtract those. So if you said 14.4, it's 14.4 per 1,000 people. So that means divided by 1,000. So that growth rate is 0.144, or as a percent, that's a 1.44% growth rate. But you can see as the years went on, in 1995, China's growth rate went down to 1.17, and in 2016, it's 0.47%. Like they're really seeing that getting closer and closer to being a negative growth rate. In the U.S., I got very small numbers for this. I got in 1980, I got 0.68%. In 1995, I got 0.65%. And then in 2016, I got 0.43%. So the U.S. is definitely not growing as fast as China was growing. But in 2016, you can see they're almost the same. But in 1980, right, that's when China was still growing a lot faster. So growth rate is birth rate minus death rate. Okay. So as I was writing the test yesterday, I was trying to figure out, like, what do I think is most important? Here, let's pause it. So the logistic growth stuff. So the question that I put on the review was just like one that we did in the examples, but it was kind of extra complicated because you had to solve for R first and then plug it into the formula, okay? I decided on the test, I'm just going to tell you what R is and put it in the formula, which we also did one like that. So I can go back in the notes and tell you. But on this one, because they didn't give us the logistic growth rate, they gave us the annual growth rate. We had to do this extra step of solving for R, just like example 3 on 8C. But I'm telling you, on the test, I'm going to give you the base growth rate, which is what R stands for. R stands for the base growth rate. So if you see a question on the test that says the base growth rate is this, and the population is growing in a logistic pattern, because remember, logistic pattern is like reaching that carrying capacity, you can just use the R that I give you, because the formula is R times 1 minus the population over the carrying capacity. So you want to make sure that you write down that formula, but I'm telling you that on the test, I think I made it an easier problem than on this review. And I can go back to 8C and pull up that question if you want me to show you. We did one where it was complicated and one where it was just given the R value. So on this one, they wanted you to compute this and say, does it match that in 2017, the growth rate was 1.1%. So when you solve all this out, you get 1.3%, which is higher than what actually was happening. And so what that means is that probably the carrying capacity isn't correct. Like something in this isn't making sense with what's actually happening. But I'm telling you, on the test, you just need to know this formula. Okay? Also from 8D, I like these problems, but they're also kind of a pain. There's a lot of formulas. So on the test, I didn't give you any problems that you have to use these formulas for earthquakes, decibels, and pH, okay? I'm trying to remember. Maybe I put a multiple choice question, but it was just like talking about like maybe knowing that, you know, earthquake of magnitude 2 is not a big deal, but an earthquake of magnitude 7 is a big deal. Like I feel like you know that already, but maybe not. Maybe you could write down like knowing that pH scale, the higher you get, the more basic it is, the lower acidic. But there's not going to be any questions where you have to compute something from 8D. I just decided in the whole scheme of what we were doing, not that important. But if you did these problems, it is kind of, to me, it's just interesting to look at the difference in how much more something is. So on 13, they said compare the energy of a magnitude 6 earthquake, which I had to use the formula, to the energy released by a 1 megaton nuclear bomb. And they told us the energy, 5.5 times 10 to the 15 joules. Well, if I do the earthquake, I got 2.5 times 10 to the 13th, which means a magnitude 6 earthquake does not have as much energy as a 1 megaton nuclear bomb. And so if you compare those two, and I wrote them this way, but then I flipped it. I want the bigger one on top. And if you flip it over, you get 200 if you divide that. That means a 1 megaton nuclear bomb has 200 times more energy than a magnitude 6 earthquake. And so again, just kind of in terms of thinking exponential of how many times more that is. So kind of can't even imagine 200 times more. Same thing on 22. Like, I thought about giving you a question with the inverse square law, but I just didn't. But we talked about that the further away you go from a sound, the more spread out, the less intense that sound is, and it follows that 1 over d squared. So if you have a distance of 10 meters and a distance of 100 meters, you can just divide those, 1 over 10 squared compared to 1 over 100 squared. And that means it's 100 times as loud if you go from 10 meters to 100 meters. And we also learned that the pH scale, each step on the pH scale is a power of 10. So I didn't even use the formula on 31. I just knew from a pH of 3 to a pH of 6 is 3 steps. So that's 10 to the third. So that means that a pH of 3 is 1,000 times more acidic than a pH of 6. And so, again, don't stress a lot about this because I didn't put questions on the test using all those formulas. Just kind of to be aware of like that it's growing exponentially is all I really want you to know from that. Okay? But then the last thing that's definitely going to be on your test is the compound interest and the simple interest. And so one, making sure you write those formulas down. If you don't know what the letters represent, make sure you write those down. And just making sure you pay attention if it says simple or it says compound. So simple interest, remember, is A equals P times 1 plus RT. There's no exponent. It's linear. And I circled this as my answer, but it's really not the right answer because it says how much simple interest would be given. Well, I just found after 6 years, this is how much money I would have. But the question says how much simple interest, which means I really should take how much I started with from how much I ended with, which means you would have $175.50 worth of interest. And then the other two problems are compound interest. And remember that compound interest, I lose my pen all the time. Compound interest is A equals P times 1 plus R over N to the NT power. If you don't know what those letters mean, write it on your piece of paper. N is the number of times it's compounded. T is the time in years. So on the second one there, it's compounded monthly. So that's why N is 12. How much money would be there in 10 years? And then I just type that on my calculator. Can't stress enough. Show me this part in case something happens on your calculator so I can give you credit for having the right equation, but maybe not typing it in your calculator correctly. Number 5, the first part's the same as the one above it. It says they have a CD at 3.5%, compounded weekly. There are 52 weeks in a year. How much will be there after 33 years? So after 33 years, same thing. I got $634.56. Not that much after 33 years, in my opinion. But then it said 33 months. And so again, this kind of goes back to the other one, a time to double. Units matter. And so time needs to be in years. So you could just change that to a decimal, like 33 divided by 12. I just wrote 33 divided by 12 as my years, but time has to be in years. And so if it's in months, you have to convert that. And so you should get about $220. And if you had the formula right, but you didn't have the right equation, please go back and look at your calculator. Try it today. Ask me questions so we can look at it. Questions about that? So for the remainder of the time, I think you need to make sure you have your formula sheet. Use these answers, and I'll post them in just a second. use these answers along with your notes to kind of go through and decide what you want to write down. Also, tomorrow we're turning in our notes and homework. And I do believe that we had 2 days of 8B notes, but everything else, we just had 1 packet of notes, even if we spent 2 days on it. And then we have this review. So if you're not someone that keeps your stuff all organized, that's another thing you could spend some time doing, is going back and seeing if you have those. If you've been absent, maybe going back and seeing if you actually have the notes filled out, or if you have the homework done from that. Because tomorrow, each of those will be worth 5 points. 3 points for the notes, 2 points for the homework. And so you want to make sure that you have that. Okay? Tomorrow we'll take our test, and then we'll be done, other than our final exams. So, yay! Okay.